Hi, good morning, and thanks for watching the fraction overview. This is Unit 2 for Bridges, and it will help you with some of the concepts and ideas that we will be talking about in Bridges. The first slide, this is some fraction basics. First of all, the numerator is the top number in a fraction. It shows how many equal parts are counted. For example, you see 3/5, 3 would be the numerator. And the denominator is the bottom number in a fraction, and it shows how many equal parts the whole is divided into. The overview for this lesson in Unit 2 is students will use a variety of strategies to find common denominators so that they can add and subtract fractions. Money and clock strategies will help students develop intuitions about finding common denominators. So just to think ahead, to begin with the end in mind, we will be using money, thinking of it out of 100. So if there's 100, and if you had 50 cents, it'd be 50 out of 100. And thinking of clocks, with the whole being out of 60, we're going to just solve some basic fractions and finding, adding and subtracting fractions using these two strategies. We are going to, later in the chapter, find common denominators, and so it's sort of the old-fashioned way of adding and subtracting fractions that maybe your parents and I did as kids. Bridges really aims to build a foundational base for fractions, and we're just using time and money to build a really great basis for understanding fractions. Money. We're going to use familiar units of money: quarters, dimes, nickels, halves, thirds, and quarters, and it will help students figure out how to add and subtract fractions efficiently without having to find a common denominator. For example, in the picture we have a $half, which equals a half as a fraction, and we're also going to think of that as 50 hundredths. A quarter is 1/4 of a dollar, and it also can be represented as 25 100ths. A dime is 1/10, and that is also 10 100ths. A nickel is 1/20th of a dollar. It's also 5 100ths, because 5 will go into 5 one time and will go into 120 times. And then we have a penny, which is 1 100ths. Money. Thinking about money, we have 3/4 here on our sheet, and as you can see on our hundredths grid, 3/4 will take up 3/4 of our hundredths grid. 3/4 is 75 hundredths, and it can also be converted to a decimal showing 75 hundredths. Also, thinking of money, and this is an example of some manipulatives that we use in class. We use a hundredths grid, which equals $1, and we have lots of grids that have dimes and nickels and pennies and quarters. And so here we are, we're looking at 7 dimes, and it covers 7 columns on our hundredths grid, which equals 7/10 of a dollar, because that's 7/10 of a dollar, or it would be equivalent to 70 hundredths. Okay, and that would equal 70 cents. On the next little box, you will see 11 hundredths of a dollar. Well, you'll see 1 dime or 1/10 column, and you'll also see 1 penny. So that is 11 hundredths of a dollar, which is also equal to 11 cents. Adding and subtracting fractions with money. First of all, if you get a fraction, for example, 1/4 plus 1/10, I'm going to think of that in terms of money. 1/4, as you can see, easily equals a quarter. And then 1/10 equals 10 cents, because that's 10 100ths or 1/10. We're going to add those two together. I say 25 cents plus 10 cents is going to equal 35 cents. And then how do we write 35 cents as a fraction? We would write 35 hundredths, and then we can reduce that down. Time is another strategy that we use in Unit 2 to solidify that basis for fractions, trying to understand, trying to add and subtract fractions without finding those common denominators. We really want to build a foundational base for students understanding what fractions are. Plus, it also helps students understand money a little bit better, as well as time. It's been a struggle for students to understand time because most students read clocks digitally. They have a habit of looking at the computers in the classroom to see the time, and or looking at watch or digital watches, phones. Many students admitted that they didn't have clocks in their houses, that they always looked on the microwave or the oven. So time will enable students to build intuitions about common denominators because any fraction of an hour can be thought of in terms of minutes. For example, looking at our clock, 1/4 can be thought of as 15 minutes. 45 minutes can be thought of as 3/4. And if we added those together, we would get 4/4 or 1 hour. No matter what strategy we use, time or money, we will still get the same answer. And you will get the same answer even if you found a common denominator and added them. Time, thinking of 1/2 is 30 minutes. We're thinking of our whole, which is 60 minutes, and so it would be 30/60ths, which could be reduced down to 2/4. 1/4 of an hour is equal to 15 minutes, or 15/60ths, which could be reduced down to 3/12. 1/3 of an hour equals 20 minutes. 20/60ths, which equals 4/12, which could be finally reduced down to 2/6. Adding and subtracting using time is very similar to money. First of all, if we have 1/2 plus 1/3, we're going to think in terms of minutes. So 1/2 of an hour is 30 minutes. 1/3 of an hour is 20 minutes. 20 minutes plus 30 minutes equals 50 minutes. Or it would be 50/60ths, and that would be 5/6 of an hour. 1/3 plus 1/4. 1/3 of an hour is 20 minutes. 1/4 is 15. Add those together, you get 35 minutes, which is 7/12 of an hour. Let's do a little quiz to see what we've learned so far. Which strategy would work best? If we had 1/2 minus 1/4, do you think money or time would work best? First, you have to think, 1/2, what would that equal in money? Maybe 1/4, what would that equal in money? If I'm thinking, I could think some of the examples that we previously saw, we would see 1/4 and 1/2 would come up, and I could probably use either to solve. 3/4 minus 1/5, thinking time or money, which would work best for this. All right, so 1/2 and 1/4, I'm going to go with time. That would be 30 minutes for 1/2. 15 minutes, if I subtract 30 minutes minus 15 minutes, I would get 15 minutes, which is 1/4 of an hour. If I was going to think about money, that would be 50 cents minus 25 cents, and I would get 25 hundredths. And if I reduce that down, I would also get 1/4. For 3/4 minus 1/5, I would probably think of money because 1/5 easily equals 20 cents. 3/4 of a dollar is 75 cents, and minus 20 cents, you would get 55 cents. 55 hundredths would reduce down to 11/20ths. The money model would work better mainly because of the fifths. Which strategy works best for 2/3 minus 5/12, or 4/5 minus 1/10? All right, and so let's look at some answers. 2/3 of an hour is 40 minutes. 1/3 of an hour is 20 minutes. If we said 2/3, it would be 40. And then 5/12 of an hour is 25 minutes. 40 minus 25 is 15. And 15 minutes equals 1/4 of an hour. And that clock model works best with 12ths. And then I have 4/5 minus 1/10. And if I doubled 4/5, I would get 8/10, and that kind of works better with money. So 4/5 of a dollar is 80 cents, and 1/10 is 10 cents. I subtract, I get 70, and 71 hundredths would reduce down to 7/10. Let's just review really quickly. Any fraction with a denominator that is a factor of 60, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, can be represented as part of the 60 minutes in a whole. And then any fraction with a denominator that is a factor of 100, 2, 4, 5, 10, 20, 25, 50, can be representative as part of the 100 cents in a dollar whole. All right, the context of time and money are natural ways to ease students into thinking about adding and subtracting fractions with like and unlike denominators. My advice to parents and students is just keep calm and enjoy fractions. We're building a strong foundation in understanding fractions. We will get to lowest common denominator, greatest common factors, and we will be adding and subtracting fractions the old-fashioned way, as kids like to say it in class later. We're just trying to build that strong base for them to understand fractions. If you have any questions, please feel free to contact me, and I will be more than willing to help you out. Thank you.